In today's lab, you will be measuring the heat of different chemical reactions. To do that, you will take two styrofoam cups and put them together. This will actually represent a very crude calorimeter. A calorimeter is an instrument that measures heat. So you should know that if heat is evolved during a chemical reaction, then that is an exothermic reaction, where heat is given from the system to the surroundings. Conversely, if the reaction cools down in temperature, that means heat is taken from the surroundings to the system. In that case, that would be an endothermic reaction. So this is our crude calorimeter. We take two styrofoam cups. We put them together. This is a magnetic stir bar. We'll place that in here. Both of those go into an insulator. So here the insulator is going to be a 400 ml beaker. I actually have a 600 ml beaker, but in your lab manual it asks for a 400 ml beaker. You probably will get a little bit more tighter fit with a 400 ml beaker. And another thing that we will use is, well, how do we measure heat? Okay, whether it's exothermic, temperature rises up, or an endothermic reaction, the temperature cools down. We'll use a temperature probe. So this little cardboard square is a lid, and we can put our temperature probe in here. All right. So that is our very crude calorimeter. Once we interface it to the instrument, we can measure the temperature. So the first reaction that we will actually do, there's 4 reactions, is one involving sodium hydroxide and hydrochloric acid. So you want to take this out. So you'll pour your sodium hydroxide, you'll pour in your hydrochloric acid, all right, and weigh the solution. So our 2 styrofoam cups, here's our magnetic stir bar. Our first reaction will be putting in 20 mL of HCl with 20 mL of NaOH. So we will take 20 mL of NaOH. This is a strong base, NaOH. So I'm going to pour out 20 mL here. That is your NaOH. And here is your 20 mL of HCl. Under Chemistry Labs, click on that. And then you're going to click on Enthalpy of a chemical reaction. Here you'll have temperature on the y-axis and time on the x-axis. Now that I got my temperature probe is hooked up to the adapter and everything seems fine with the computer screen, I'm ready to begin commencing my reaction. So the first reaction is sodium hydroxide with HCl. So here is my styrofoam. Okay, here's my little stir bar. Okay, so put that in here. Let's put that snug in. So the first thing you want to do is pour your NaOH in. So this is my NaOH, 20 mL of 2 molar NaOH. I'll turn the stir bar on so that I get some stirring. So here you may have to play around so that the stir bar actually stirs. If the stir bar does not stir, you may want to use this for stirring. Okay. Now I put my sodium hydroxide in. Let's go back here to the computer screen. I got to get everything ready here. So this is where you're going to work with your partner. I'm going to click on Collect, that green Collect button, and you see I am collecting data. All right. The temperature is pretty stable at 21.6 degrees. Well, you know, this is not being connected to anything, so obviously it's going to be stable. I'm going to get ready now. I'm going to put my temperature probe inside this little cardboard tube. And if you can zoom in here, I'm going to add now my HCl. Once I add my HCl, I got to do this kind of quick. Once I add my HCl, you should see the temperature on my computer screen either go up or go down, because once I add my HCl, it will react to the NaOH already in the calorimeter. So here we go. 3, 2, 1. I'm adding my HCl. You got to go quick here. And I'm going to stir this around. Now look at the computer screen. So I'm actually stirring it with my temperature probe. And if you have the computer screen on, you can see what has happened to my temperature the minute I added the HCl to my NaOH solution. The temperature has shot up. Okay? The temperature has shot up, and now what is happening in real time? What is happening in real time is now that temperature has plateaued or leveled off. Okay, so I'm going to let this go for, I guess, maybe a couple of more seconds. I'd say maybe 20 more seconds. Really, the graph is complete, but just for aesthetics, I'll let this go till maybe up to 150. But the temperature has cooled off now. Okay, the temperature has risen, and now the temperature is pretty stable. Okay, it's steady, it's a straight line. And so I am done with this reaction. So when you're done, click stop. And that is my first reaction involving NaOH and HCl. Remember, the NaOH was inside the styrofoam cups. The HCl was poured at around this step. Right here, I poured the HCl, and I started mixing with my temperature probe, and then the temperature rose up. I could actually zoom in on this. So I'll click here and change this from 40 to 30, or maybe 30 sounds like a good number. Okay, and I can change this bottom number in my x-axis from 15. Let's make it 20. So from 20 degrees to 30 degrees, here's what my reaction trajectory looks like. You want to do this twice. Okay, you're going to want to do this twice. So after you do this, you're going to do your data analysis. So for your data analysis, you will go here. So click on Stat. Okay, if you see that, there's that Stat button. It says Stat. Click on Stat, and this box comes in with your statistics. What you're interested in is your minimum temperature. Okay, so the minimum temperature was 21.58. That was the temperature about here. And then the maximum temperature was 28.12 degrees. That is the maximum temperature it reached once I added the HCl. So note down your minimum temperature, and then the maximum temperature that has come off, or the maximum temperature that the system reached once you added the HCl. So collect this, do this reaction one more time, and average the temperatures. So you want to do this as a duplicate. Okay? So the first reaction, HCl and NaOH, and then the second, third reactions you will perform in a similar manner. Just one final word on calculation of your enthalpy for these reactions. You want to get the heat from the system. Now what is the system? Okay, the system is actually the NaOH, the HCl that were mixed in together, in which the temperature rise was calculated. So this is the system. Everything else is the surroundings. You want to calculate the heat of that reaction inside those two styrofoam cups. So in order to successfully do that, you will also need this equation. The heat of the system is equal to minus the heat of the solution minus the heat of the calorimeter. That's going to be constant because the heat capacity of the calorimeter is going to be constant. So really, the main roles or the factors that play a role in your enthalpy is your change in temperature. Okay, how far the temperature goes up or how far the temperature goes down once you add those two reactants together. Right? So by doing this, Q system equals minus Q solution minus Q cal, you should get an answer. in kilojoules per mole. That is, the units of this are in kilojoules. You're going to divide it by the moles. And as I stated before, the moles are going to be the same because 20 mils times 2 molar is the same amount of moles, whether it's NaOH or HCl. So that's how you're going to perform this reaction, and that's how you're going to perform the calculations, I should say, for determining the final enthalpy for this reaction, and this reaction. Do not forget that once you get your heat, divide it by the number of moles of the reactant.